Hi there, welcome to the last lesson of arithmetic of surds. This time we're going to be dividing surds, but this time we're going to be dividing by a surd into a number. Now it's unacceptable in mathematics to leave your denominator as a surds. As the problem is the surd on the denominator, what we've got to do is try and find a way to get rid of the root 3 from the bottom of this surd. Now what we do know is that if we have 4 divided by a root 3, the only way we can get rid of a square root is if we can turn that into the square root of a squared number, as they are opposites that we cancel out. So in this case what we need to do here is we need to multiply top and bottom by the square root of 3. Now you think normally when you multiply by a number, that number is going to change the answer. It's usually going to get larger. However, if you multiply by a fraction which has the same number top and bottom, it's the equivalent to multiplying by 1. And any time you multiply by 1, then the answer is the same. So in this case here, even though we've multiplied by root 3 divided by root 3, it's not going to change the value of the final answer. But by doing that, we end up with a situation where we have 4 root 3 at the top, but we have a root 3 squared down the bottom. And this is the condition we're looking for, where we can cancel off the root and the squared and just be left with a whole number. So when we do that, we end up with 4 root 3 at the top, and the square root and the square root cancels with the squared to give us just 3. So we now know that an equivalent way of writing 4 divided by root 3 is 4 root 3's all divided by 3. And this is an acceptable form of writing the answer. So this process is what's known as rationalising the denominator. And the kind of example you might find in an exam looks like this. It will simply say, rationalise the denominator in the surd 2 over root 8. Well, the solution for this, we start with 2 root 8, and we want to get rid of the number on the bottom as being a surd. So what we'll have to do is we have to then multiply top and bottom by root 8. Now we know that's 1, so it's not going to change the value, but we end up with 2 root 8 divided by the square root of 8 squared, and we know the square root and the squared cancel, and that's just going to leave us with 2 root 8 over 8. Now we can't just leave our answer there. When we're looking for it in an exam, we want to display all the information correctly, and we want to do all the processes that simplify what we've got into its smallest form. So first of all, we can see that 2 over 8 cancels to 1 over 4, so we end up with a quarter of the surd. But we also know that root 8 can be simplified even further, and it becomes 2 root 2. And then that then in turn gives us something else that can cancel down, and we end up with simply root 2 divided by 2 is the equivalent surd in its simplest form from the original value 2 over root 8. Right, so what I want to do now is I want to try and do the exact same thing with the surds that are in these questions. So start the movie, try them for yourself, and we'll go over the answer shortly. So the first one, we have to multiply top and bottom by root 5. Root 5 times root 5 gives us 5 in the bottom, and the top one becomes 3 root 5. Next one, we're multiplying by root 7, so 5 times root 7 at the top, root 7 times root 7 at the bottom gives us root 7 squared. The root and the squared cancels just to leave us 7, so the final answer, 5 root 7 over 7. And the next one, multiply top and bottom by root 2, we're going to end up getting 4 over 2 root 2, which can simplify further to give us 2 root 2. Next one, we're multiplying top and bottom by root 3. In this case, we get 9 root 3 at the top, root 3 times root 3 squared down the bottom, which simplifies just to give us 3. And once again, 9 can divide by 3, and that leaves us with the answer of 3 root 3. Question number 5, obviously we have to multiply by root 11 this time, so it's going to give us 6 root 11 up the top, and the square root sign, you can now see in most of these cases, it just disappears to give us the number left. So in this case here, it doesn't simplify any further, and 6 root 11 divided by 11 is our final solution. Next one, we have 5 root 5 divided by 5 for the reasons mentioned before, and this time you can see the 5's are going to cancel, simply to leave us a nice root 5. 7 root 3, so that's going to give us 7 root 3 all divided by 3. That one there's not going to simplify any further, so that's the final solution. And the last one, 1 over root 5, multiplying top and bottom gives us root 5 over 5, and that's us finished. Okay, so hopefully you'll be able to try a few for yourself. The teacher's going to give you out the exercise, and thanks again for listening.